7.1 is talking about symmetry. Okay, this is the important part here. So if we fold these types of graphs on the x-axis, the parts above the x-axis and the parts below the x-axis will coincide. So you can see right here that this, if we fold this on the x-axis, this point would end up being on top of this point. Y'all agree with that? When you look at the coordinates, this is also important. X, Y, the X stays the same. It's 4 and it stayed 4, but what happened to the Y? It went from 2 to -2, so it became the opposite, right? So whenever something is symmetric about the x-axis, the X is going to stay the same, but the Y point is going to be the opposite of what it was, okay? Another thing that we look at is what happens whenever it's symmetric about the y-axis. So here's my y-axis. So that means if I fold it on the y-axis, this point should land on this point. So if you look at the point 3, 4, xy changes into -3, 4. So the x becomes negative and the y stays the same. So it's kind of opposite of what you think. If it's symmetric about the x-axis, the y is the one that changes. If it's symmetric about the y-axis, the x is the one that changes, right? Okay. Symmetric about the origin. So basically, if it's symmetric about the origin, if you started off with -x, -y, it becomes +x, +y. So both of them change. And what's really happening is you are able to rotate this thing 180 degrees, which means you're turning from front to back, right? Not all the way around, but you're turning from front to back and it lands back on top of itself. So this is one you can rotate 180 degrees and it just ends up on top of itself. The origin is this point right in the middle, 0, 0. Okay. So symmetric about the x-axis, y-axis, or the origin? Y-axis. You can visually see that if you fold that on the y-axis, those points would land on top of each other. This one is going to be the origin, because if you could rotate that 180 degrees and it's going to end up back on top of itself. Symmetric about the x-axis, because if you fold it on the x-axis, it's going to be on top of itself. Y'all okay with that? What about this one? It's symmetric about the y-axis. You're absolutely right, because if we fold it on this y-axis, this point is equal distance from this point. So y-axis. Okay, so if these words are important, sometimes functions can be even, sometimes they can be odd, or sometimes they can be nothing. If a function is even, it is symmetric across the y-axis. If a function is odd, it is symmetric across the origin. If it is symmetric across the x-axis, it is nothing. We don't care. So if you get one that's symmetric across the x-axis, the answer is going to be nothing. Okay, so y is even, origin is odd. So this one is symmetric across the y-axis. You can fold it on the y-axis, so it's even. This one could be rotated 180 degrees. So it's symmetric across the origin, so it is odd. What about this one? Okay, could you rotate it? This one's kind of difficult to see, but can you rotate this 180 degrees? And it will be back on itself, top of itself. Kind of have to, if you think about turning your paper completely over, like upside down, would it look the same? That might be a better way to say it. Yes, like physically do it. Take a paper and turn it upside down. It's odd. I was having some head shake still. And here's the deal with this, because so it's symmetric about the origin. Sometimes it's just difficult to see it. And I agree with you. This one is symmetric about the y-axis. So it is even. This one is nothing, right? So neither. It's not even symmetric. It's not symmetric at all. About the x-axis, the y-axis, nothing. This one's symmetric about the x-axis. So that's a neither. Okay. Questions about that? The key here is remembering those, which one, which one goes with what. Okay. This is a bad picture. This little W looking thing is not supposed to be shifted over. So it is supposed to be right there in the middle of that. So it is supposed to be symmetric across the y-axis. So it is actually even. I do have a few students who are engineering majors, and this is not on the computer lab, but if you want to know mathematically without looking at the graph, whether it's even or odd, what you do is if you plug in, let me write this down real quick. If you plug in h of negative x and it gives you back h of x, that function is going to be even. If you plug in h of negative x and it gives you back a negative h of x, that function is odd. So on this problem right here, if I plug in a negative, sorry, let me erase that. If I plug in a negative x right here, that would be negative x to the fourth minus 4 times negative x squared. Well, when you raise something to the fourth power, you're doing negative x times negative x, so it's back to positive, right? Negative times negative. Times a negative times a negative. If we do it 4 times, it's going to be back to a positive x. Okay, same thing here. This is going to be a negative x times negative x. If we square it, it's going to be positive. So negative 4x is what we would get. How is this one related to this? They're exactly the same. Y'all agree? So that function is going to be even. When I plug in a negative x, I get back what I started with. Okay. So if I write down, bear with me, this will just take a second. If I write down my function is h of x is equal to negative 3x to the third minus x, and I want to see if it's even or odd, when I plug in negative x for my x, well, this is going to turn into a negative x times negative x times negative x is going to be negative times negative 3. That's going to be positive. And this is a negative negative x, so that's going to be positive. How are these related? They're exactly opposites of each other. If this is negative 3x, this one's positive 3x. This is negative x, this is positive x. So this one is odd. If I have h of x is equal to 2x squared minus x plus 3, and I plug in a negative x for that one. Okay, this is going to turn into, this is going to say 2x squared. This is going to turn into a positive x plus 3. Well, this is okay. These are both positive, but this one is the opposite, and then this one is back as positive. So this one would be an example of something that is not, it's neither one, because everything wasn't the opposite or the same. Does that make sense? Okay. So I will see you guys in lab.